All right, folks, welcome back to another segment of analytics for decision making. In this segment, we're going to work through a very simple example to derive the option value of a piece of information. And the way we're going to do this is by using a three-step approach here. The first step is going to involve us computing the expected payoff to an individual in the absence of the relevant piece of information that we're going to be considering. So we'll figure out how well off are they without the information, and we're going to assume that they are behaving optimally ex ante. Ex ante means before any uncertainty is realized. Then next thing we're going to do is we're going to figure out what their payoff is using the information. How well would they do if they had the information? And again, we're going to assume that they are behaving optimally with this information. And then the final step in the process to compute the value, the option value of this piece of information, is to essentially compare the expected payoffs in steps 2 and 1. By how much did using the information cause the average payoff to increase? So what we're going to then do is we're going to compute the difference between the expected payoff with the information less the expected payoff without the information. And if you're wondering why we're taking the maximum of that value and 0, I'll touch on that in a moment. But the idea basically here is the value of information can't be negative. So if that term in the yellow box was to be negative, okay, the max function makes sure that the value would still be 0. And that's because information can't really make you worse off in this context. If it did, if it lowered my payoff when I used it, I would just choose to not use that information. I would ignore that information. So we're going to go ahead and we're going to jump into a fairly simple example that I'm going to refer to here as the Manhattan hot dog vendor example. And we're going to consider a situation faced by a typical New Yorker deciding where to purchase some food from a street vendor. This particular case is going to be hot dogs in Manhattan. And to simplify our analysis here, we're going to assume that the quality of hot dogs across vendors is identical. So they are, for all intents and purposes, a homogeneous product. And we're also going to ignore, a realistic component of spatial features, right? How far does it take to go to one vendor versus another? We're just going to assume that the vendors are equidistant from where we're coming from. So given that setup, the only thing an individual would care about when deciding to go to one vendor location versus another vendor location is where they can get the cheaper hot dog from. So we're going to assume that the individual is an expected cost minimizer. They're going to choose the action that results in the cheapest hot dog purchase on average. And we're going to assume that there are only 2 possible vendor locations to choose from. And the uncertainty here is the individual doesn't know at a particular choice of location if it's the low priced hot dog vendor they're going to run into or the high priced hot dog vendor that they're going to run into. So again, one of the vendors sets a pretty high price of $10 per dog, but the other vendor prices hot dogs at a 50% discount relative to that. And unfortunately, the fundamental uncertainty that we face as the individual that we're empathizing with in this situation is we do not know which vendor is going to show up at which of the 2 locations. And because of that, we basically just assume it's going to be a coin toss, meaning the individual, us, if we're empathizing with them, is equally likely to choose either of the 2 vendors on a random stroll to work past either location. Now, the reason why this is called the Manhattan vendor example is because Manhattan streets are set up in a very particular way according to what is known as a grid metric. So imagine your apartment is here on this corner and you need to go to work, which is on the opposite corner. And there are 2 potential vendor locations that we could go to on our way to work. We could either take the north and then east route to get to work, meaning we would pass the top left, right, that north west vendor location, if you will, or we could have gone first east and then north by taking route 2. Okay, so again, the uncertainty here is we do not know which vendor is going to show up at which location. One vendor is going to charge $10, one vendor is charging $5. We don't know who is going to be where. All right, which means without any other information, we basically are facing a coin toss. If I was to go route 1, there's a 50% chance I'm hitting the high priced vendor, right? Or conversely, if I was to go the other route, I'd also face the same uncertainty there. Okay, so the question is here, at any location, is it the high price or the low price? If the high price is at one, then the low price is at the other, and vice versa. And in thinking about this, we're going to answer the following question. We're going to think about how much would it be worth to the individual to know in advance where the cheaper vendor is located. And this is going to lead us into this discussion of the option value associated with this piece of information, the knowledge of the cheaper location. And again, in order to answer this question, we're going to apply our 3-step approach here. Step 1, let's figure out what is the expected cost to the individual in the absence of knowing where the cheaper location is. And if we do not know where the cheaper location is, again, we mentioned we basically face a coin toss between either paying $5 or paying $10. And notice I've put negatives there because we're thinking about these as payoffs. The more you have to pay, the worse off you are. You could also think about the negative there being consistent with an outflow if you're in the accounting vein of thought. So the average amount of payment that we would make, the expected payment with no information, would mean we face a 50-50 chance of either paying $5 or $10, which means on average we're going to be paying $7.50 in the absence of the knowledge of the cheaper vendor location. And now the second step in this process requires us to then think about the payoff that we would achieve if we had the information that was relevant here. So now we want to think about, well, what's the expected payoff, right? Cost really in this case to the individual if they had the knowledge of the cheaper location. But we want to remember they're not just going to do anything anymore. If they have that knowledge, they're going to behave optimally, which means the optimal action that a rational individual will always choose with that information right after the fact is going to be to always go to the cheaper location. A rational individual would never go to the more expensive location, given that the products are homogeneous, right? Same exact quality hot dog, same distance walk. The only difference was the pricing. That makes life easy. That means in step 2, the expected payoff with information just becomes the $5 cost, right? -5 outflow, which we would be paying for sure. We would never show up at the more expensive location if we knew where that was. Okay, now we can go ahead and given those 2 payoffs, to compute the value of information, we just need to understand, well, how much has the payoff increased with information relative to not? So all we need to do to compute this is take the value, the expected payoff with the information, which was a -5 price we paid, less the -$7.50 price we were paying on average without information. And if we do that, we see that the value of this piece of information winds up being $2.50. And hopefully that makes sense here, no pun intended, that knowing the vendor location, right, means you're going to pay $5 for sure, whereas not knowing that you face that lottery, a 50-50 chance between paying 5 and paying 10, right? So you could have been paying $7.50 on average without the information. With the information, you pay $2.50 less on average. Hopefully that was a fairly simple example to follow. In our next segment, we're going to jump into a somewhat more complicated case. The narrative is a little bit different. We're going to be dealing with an oil drilling situation. So please join us for that segment. I will see you then. Take care.